People with O negative blood are called universal donors because O negative blood can be given to anyone else, regardless of the recipient's blood type. Only about 6% of people have O negative blood. If donors line up at random for a blood drive, how many do you expect to examine before you find someone who has O negative blood? What's the probability that the first O negative donor found is one of the first people in line? Chapter 17, we are going to use geometric models. If you're not sure some of the terms that I'm using as I'm going along, it might be a good idea to read chapter 17 and then take a look at the terms at the end of the chapter. First thing we need to do is we need to check that these are Bernoulli trials. So there are 3 conditions that we need. First, we have to make sure that we have a success. So our success, which is having O, and our failure would be not type O. Our second condition, we are going to find the probability. So it says 6%. So P of having O is 0.06. So there's a 6% chance for all donors that they will have O. A third condition, we have to make sure that each event is independent. We're not sure that one person is independent of the other. Think about it, if I have a parent that has O type blood, I might have a better chance of having it. But since our population is less than 10% of our entire population, we are okay. Of entire. Okay, so again, we need to have, if we're not sure if it's independent, it needs to be 10% or less of the entire population. So figure if I only have 200 people coming to my blood drive, there are millions of people in the world, so 200 is definitely less than 10% of all the possible people who could donate. Next part, define the random variable. If you're not sure what that term means, might be a good idea to read chapter 17. So let X equal the number of donors until one is type O. Which I think we want type, right? O negative. So I'm going to add O negatives, not type O negative. Find the mean. So this is really asking us to find the expected value. Now, since it is a geometric model, we have a new formula we have to remember. But it's, again, expected value is usually pretty easy, so this isn't bad. It's going to be 1 over the probability. So 1 over 0.06, which is 16.7. So that takes this percent and makes it into a number of people. So we expect 16.7 donors at an average blood drive to have O negative blood. Calculate the probability of success on one of the first 4 trials. That's the probability that we have an O negative donor on the first person, second person, third person, or the 4th person. Or is our key here. So we are trying to find the probability that we get a donor on or before the 4th person, which means we really need to find the probability that it's the first person, or the second person, or the third person, or the 4th person. Notice that I'm saying or, so I have plus signs in between each of these probabilities. So the probability that the first person walks in has O negative, they have a 6% chance. The second person, right, it's not till the second person. That means the first person is not, and the second person is. It's not until the third person that I have an O negative, so it's a not O negative, second person is not, and the third person is. And the 4th person, notice here that I could say the first 3 are not, and the 4th has O negative. When I do this all out in my calculator, okay, I get 0.193 0.3 or 0.2193. And what does that mean? That means about 16.7 people will be universal donors at every blood drive. We can expect to get a universal donor in the first 21.9% of the time. Now, some of you might be asking, well, how do I know that it's going to be 16.7 people if I never said how many donors? Well, we got that 0.06% based on the typical number or the average number of people that we expect at each blood drive. Our calculator is going to come in pretty handy for this, or sometimes there are statistical programs out there that will do this for us. But we are looking for GeoMet PDF in our calculator. So we can find that by going to Second FARS and selecting E, and then hitting enter. Notice down here that I have the CDF, so right now we're going to work on PDF and we'll talk about the difference. Okay, PDF allows you to find the probability of any individual outcome. Okay, so our first example says find the probability the first O-negative donor is the 10th person. This is a little different than what we did on the front because I want the 10th person. I don't want on or before, I want just the 10th person. That's actually why I have this P here. Okay, so I want one instance. I don't want it to be the first or the second or the third. I want it to be just the 10th. So I want it to be the 10th person. So what I'm going to do in my calculator, so I have GeoMet PDF, my probability of having O-negative was 0.6. I want it to be the 10th person. When I hit enter, I get 0.03437, which is about 3.4%. The next one, find the probability the first O-negative donor is the fourth person. So probability that it's the fourth person. Again, go ahead, set it up in your calculator. Probability is 0.06. It's the fourth person this time. I get 0.0498, which is about we'll leave it at 4.9%. Just about 5%. Find the probability the first O-negative donor is the 7th person. Go ahead, hit pause, and then check your answer with my work. Hopefully you got 4.1%. Now we have GeoMet, or GeoCDF. This calculates the probability of finding the first success on or before the X trial. So this is what we did on the other side. Guys, which is going to make it a lot easier, especially if we have like on or before the 20th person. That can get kind of crazy to do by hand. So example 1 says find the probability of success of getting an O-negative donor on or before the 6th person to walk in. So this time I want it to be less than or equal to 6. So similar to the front, make that a 6. Okay, this means it could be the first or the second or the third or the fourth or the fifth or the 6th. That's a lot of probabilities to add up and do by hand. You should expect to be able to do it, maybe up to the 4th person in any situation, but anything usually bigger than 5 or 6, you can use your calculator. So I have probability X is less than 6. So in my calculator, I have GeoMet CDF, again my probability, and this time I want 6. When you do this, you should get 0.3101, so it's about 31% chance that it happens on or before the 6th person. Find the probability of success of getting an O-negative donor on or before the 8th person to walk in. So again, this could take quite some time if I had to do it by hand. P is less than or equal to 8. So my calculator, GeoMet CDF, C actually stands for cumulative, which means adding it all up. Think of cumulative tests. They have a lot of information on them. So 0.06, 8. And I get 0.3904. So there is about a 39% chance of getting an O-negative donor on or before the 8th person.